Okay, so this problem says in the figure below, determine the point other than infinity at which the electric field is zero. Okay, so it could help just to look at the problem first and try to reason out where this particular special point could be. If they had both been positive charges, then somewhere between them would make sense. But since one's negative and one's positive, the field is definitely going to point to the left at all points between them. Now, if you're on the left side, part of uh, the attraction you would have would be toward the negative. If you're a positive test charge, you'd be pulled toward the negative, but you could also be pushed by this guy. And same kind of thing would happen over here. If you're a positive test charge, you would be repelled by the thing you're close to and attracted to the negative. But over here, it's not possible for E to equal zero. The reason why is you're going to be strongly repelled by the positive charge because it's big size and it's closer to you than the negative. So here, it's not possible for E to equal zero. Only on this left side of the negative is it possible, if that makes sense. So now what we want to do is find the fields at this point P. Okay, so the E total at point P has to be a combination of E due to the first charge plus E due to the second charge. And we want that total to equal zero. Okay, so in other words, we need E1 to equal the opposite of E2. Or in other words, we simply need the magnitude of E1 to equal the magnitude of E2. So what I would do next is plug in the formulas for E1 and E2. But since we're dealing with the magnitude, we want to use absolute value here. Okay. Now I will see that the k's cancel. We can plug in our charges, and we want to plug in the distances too, but we need to come up with an expression for the distances. So I can call the distance from the negative charge just x. Okay, so x is r1, right? So I just want to replace r1 with an x. Now when it comes to r2, that's a farther distance. Okay? R2 is going to be 1 meter plus x. So I'll have that. We want them in terms of x. The next step would be to solve using either an online calculator or you could do it by hand. I like this symbolab.com, and it gave me 1.6. So x is 1.6.